Welcome back to our new video. Today we are going to move ahead from binomial theorem to geometric distribution. It's gonna be very fun and you're gonna enjoy a lot. So let's start our new topic, which is geometric distribution. So it's just an extended version of binomial theorem, binomial distribution. So let's see what is actually wants to mean it. It's just like when will we will win after how many tries? What is the probability of winning after 3 trials? What is the probability after winning 10 trials? So we're gonna learn from here how does geometric distribution actually works. So like I already told you, like Bernoulli for one, binomial for fixed, and geometric keep going until we get succeed. So geometric tells us how much we need. So means we need to understand how much we need to success. So let's get started. So what is the basic and core difference between binomial distribution and geometric distribution? So if I perform 10 trials, how many successes will I get? This is what binomial asks. Geometric will ask how many trials do we need before we get first success. So like for getting everything first, we will use geometric distributions. So let's start with very simple question. To get the first head in the fourth toss, what is the very probability? So that means we have to win in our fourth chance. Means the preceding three we will fail. So the probability of failing is 0 0.5, 0 0.5, 0 0.5. So 0.5 power 3 raised to 0.51. So which is 6.25% chance of exactly getting 3 failures followed by 1 success. So it's quite very low. So it is means very tough to get the fourth head if we already get 3 failures. So let's start and derive the formulas. So let's see, we have two K trials. K trials in which we will get the success. So how many trials we will got failure? It's very simple. It's K minus 1. So we'll put the simple formula. Probability of success is P. Probability of failure is 1 minus P. So K minus 1 into P, which is like just a simple K minus 1 and P, the distribution that we have already discovered and learned in the binomial distributions. Let's get to the next part. Like how does actually it works in trading model? Let's suppose our trading strategy is 0.4 probability of generating a profitable trade. So what is the probability that the first profitable trade occur exactly on the third attempt? Means the two previous it will fall. So P x equals to C 1 minus 0.4 power 2 into 0.4. So it's 14% chances that we will win in our third trade. So which is quite low. But it tells us set as a realistic benchmark for our strategies to be trained. So let's start and understand what is expected waiting time, which is like 1 upon P. So its probability is 0.5. Our expected wait time is 2, is 0.2, it's over 5. It's very simple. But that doesn't guarantee us to win, that we will win a profitable trade on fifth. It's just a representation. It's not guarantee, it's just a representation. So this is the graph of geometric distribution, which is kind of similar to exponential decay, but it won't, but it is kind of similar. So for getting the variance is y minus p upon p square, so our deviation is root 2. So we can measure the uncertainty of our weight. So let's understand very simple probability of decay. The probability decreases the longer we wait, because the later success requires a longer unbroken chain of consecutive failure. Rare success figure 0.1 stretches the waiting time, creating long fate trails. So if our probability is 0.2, which is higher, our expected time is much lesser. Let's say our probability of winning is 0.9, so it's expected that we will fail 9 times until we get succeed in our 10th. So what is that secret? It is memoryless. It doesn't care what is the result we got in the previous trials. So it is a memoryless property, and you can see the mathematical representation in probability px greater than s plus t divided by x greater than s equals to px greater than t. The probability of success on the very next attempt remain exactly the original p. That means a memoryless function. So for any things that is does not depend on the preceding results, we can use this distribution. But why does actually it fails in finance? Because in finance they are not memoryless. They are often clustered together when market panics and momentum happens. So it's not memoryless properly. So that's why it's not very perfectly applicable in life. So let's talk about revised our diagnostic metrics, core question distribution, one success Bernoulli, number of success is binomial, and trial until first success is geometric. So we have some homework questions for you. A point is point 0.5. You can clearly see in the screen. So let's get what we're gonna do. The next is negative binomial, which is also very crazy thing. So we're gonna learn this in next topic. Until now, I hope you really enjoyed this video. See you soon. See you in the next video. Bye bye, guys.